are there any topics or examples of the rule that you are unsure of? So if we look at those representations, is there anything that you'd like to clarify before we start? And also let me know in the chat, what did you do today in school in maths? I'm curious to know. So 2 questions. Anything you want me to go over in the rules? We're going to use them tonight. And what did you do in maths today? Okay, and then Stephen, give me a thumbs up when you're ready to roll. Are you ready to get going? I know other people will join as we go, but let's get the show on the road. Welcome to Ntsakeni, who's joined us. Ntsakeni, we're just having a quick look at the things that we did in previous lessons. Today is going to be a combo lesson of these topics, and I just want to see if there are any questions before we start. Perfect. Okay, well then let's get going. So let's see what we can do if we combine these rules together into a question. And I'll leave this up as a sort of helpful formula sheet. And the first question for today is going to be to find the length of AC. So let's go and find AC. It's over here. What tool do you think I should use to find the length of AC? If you look at the top here, there are 3 choices. What tool would you use? What tool would you use? So we'll think back when we have 2 sides. We have 2 sides. So there's a side and there's a side. And we also have the included angle. And we want to find the 3rd side. What rule are we going to use? We're going to use the cos rule. And so we're going to be in this part here, but there's 2 choices. We can focus on angles or we can focus on sides. And since we want sides, I'm going to suggest that the template for this is going to look like that. So, and then we have minus and then cos of that angle. So I want you to take that template and see if you can put the numbers from here in here and get the answer for AC. Okay, so that is where we're at. I'll wait a little bit of time to see for those of you who can do it at home. We are definitely going to use the cos rule for this, but you need to figure out what goes here and then get me a final answer. And if there are any questions that you'd like to ask, you can just ask in the chat. Okay, so we are going to take 12 and put that here. 20 goes there, 12 goes here, 20 goes there, and the angle between is that. So now you've got all those things, but you've still got to deal with the square. So you have to ask yourself, what undoes a square? It's a square root. And so what you are going to do is you're going to square root. So in your calculator, you are going to put all this stuff, and then you're going to square root it. And I want to see what answer do you come up with for AC. So welcome to Siamtanda, Nkateni, Tsapang. We've just started our lesson, and we are focusing on using all the rules to solve different problems. And the first problem was to find the length of the yellow AC using the cos rule. And I'm just waiting for answers to come in now. And welcome to Silicane, who's also joined us. So if I put in my calculator, I'm going to put square root 12 squared plus 20 squared minus 2 times 12 times 20 times cos of 110, but I need to close the bracket, and I hit equals, I get an answer. I want to see what you guys get in the chat. What you get for your answer here. And then we can see if we agree. Okay, so what I get, give me a thumbs up if you agree. I get 26.61, but it says to 1 decimal place. So this is going to be 26.6 meters. Obviously, Mtanda agrees with me. Fantastic, fantastic. Okay, so we've got this yellow one here. That was the first question. The next question is to find the size of angle BAC. Where is BAC? Okay, BAC is going to be this green dot down here. I want to know what rule should we use to help us find that green dot, given the information that is currently there. And we might have more than one choice. So if we have a choice, then just choose whichever one you think would be best. What rule would you use to find BAC of the 3 rules on the top here? So Siamtanda said the sine rule, and I agree, Siamtanda. I would also be pretty drawn to the sine rule because I see an angle at a side and an angle at an opposite side. So for me, the sine rule is also probably the best choice. You could use the cos rule and you use these 3 sides, but I think it would take longer. It's not wrong. You could use the cos rule, but in this case, I think I would just go sine of BAC over 12, which is opposites, is equal to the sine of 110 divided by what's opposite that. Now you still have to do some work, so I'm going to give you some more time. What is the size of this angle? That's what you need to work out for me. The 12 is a bit in the way, and the sine that's connected to the BAC. What do we get there? So I know I'm going to move that 12 across, but I still need to get what that actual angle is. So I'm going to look at the chat and see if there are any suggestions coming forward. Thank you, Simtanda. Anybody else have an angle? I'm going to try in a moment. I'm going to go shift sine. So that's going to get, and then I'm going to go fraction 12 sine 110 over 26.6, close bracket, and I get 25 degrees as well. So this is what I get. This angle over here is going to be 25 degrees. Okay, so we've done that one and we've done that one. Let us keep going. Calculate the size of D correct to the nearest degree. So there is the angle D. What rule do we need to use to figure out this one? What rule do you think we should use to figure out this one? And I'm curious to know if Stephen has any ideas, or if Sapang has any ideas, or Ntakeni has any ideas. What rule do you think we should use for this process of finding the angle D? I'll call it the red dot angle. Oh, Annalena has given a comment, and I agree. And so does Siam Tanda. We are going to use the cos rule because you've got three sides. So I'm going to write the cos of D, and I look at the top here and I go, well, I know my template has a fraction. See if you can figure out what goes in that fraction, and then see if you can get that D all by itself. I'll give you a bit of time. What do you have for that D? Let's look at that rule. We know that the side opposite the angle is always going to be the negative one. If we think back to our earlier lessons, and then we do have that, and then we have this over here. Let's have a look. So we know this is the negative one. Well, what are the other two ones that are left? The 7 and the 28. So I'm curious to know what angle you get for D. What are people getting for D? So my 7 goes here, my 28 goes there, 7 goes here, 28. And to get just D, I have to use inverse cos. But if I do it to the one side, I also need to do it to the other side. So D is going to be equal to inverse cos of that whole thing above. So let's put that into a calculator and see what we get. Shift cos fraction 7 squared plus 28 squared minus 26.6 squared over 2 times 7 times 28. Go to the end, close the bracket, and then I get equals. And what I get is I get 71 degrees. Oh, no. And I see that everyone else is getting 71. So we have 71 degrees. Okay, so we've got one more thing to do, and then we're done with this first question. So we've done that one, we've done that one. It says, find the area of the piece of land ABCD. So A, B, C, D. Okay, it's a quadrilateral. Does anybody have a strategy we could use? I don't have any rules for quadrilaterals to find the area, but maybe there's a strategy or a clever way of thinking that we can use. You can even turn your mic on and just tell me audibly if you have an idea. Anybody have an idea of a technique we could use to find the area of this quadrilateral? What do we think? What rule would you use to help you get this area? Annalena, what do you think? Do you have any ideas that pop into your head for figuring out the area of this whole quadrilateral? So Stephen, what I was asking was, if you see this pink quadrilateral, I need to find the area. It's A, B, C, D. I want to know what technique. I've got these three rules, but nothing's about quadrilaterals. What do you think I should do to help me find the quadrilaterals area? Does that help, Stephen? I don't know. Do you have any ideas? Or Annalena, do you have any? Yeah, go for it.
So you could calculate the area of the two triangles that make up the quadrilateral and then add them.
That's
That's what
clever.
I'm thinking.
Yeah. No, I think you're very cool, because otherwise, how else would you do it, right? Like, you've only got the area rule for triangles. So the only way to do it is to break it into two pieces. I'll call it the green and blue triangle. So I think that's brilliant. Okay, thank you for that tip. Everyone, let's try and find the area. And I know that there's a template for this. It's a half times one side times another side times the sine of the angle between those two sides. So see if you can find that. I think I see 12, and then I see 20, and then 110. So that would be the top one. And then the bottom one, I see the 7, and then the 28, and then the 71 between. Yeah, I think that's a very good strategy. So can anybody give me the area of ABCD? Have you worked it out? So, yeah, I'll give you a bit of time while I do it as well. 0.5 times 12 times 20 times sine of 110 plus a half times 7 times 28 times sine of 71, close brackets, equals. I have my answer, but I want to see if anybody else has the same answer as me. Who's willing to share their answer with us? Yes, I get the same. I get two. Thank you, Annalena. It's 205.42 or 205.4, and we are going to say meters squared. CM Tanda, we're on the same team here. 423, yeah, so it would be 0.4. So this entire piece of land is going to be 205.4 meters squared in area, and we used the area rule, and we just divided it up into two triangles. Okay, give me a score out of 10, how you felt about that one, where 10 is like you perfectly understood it. 0 is no understanding. 5 is some understanding, but you need to get better. How would you feel about this question? Give me a score out of 10. It just helps me know how quickly I must go for the next one. Okay, let's do another one quite similar to this one. So if we look at this question, it has some similarities, and we'll just read it together and then you can start. So you're given this shape and you need to find the length of CD. So first, let's find where CD is. It's here. There is some information already on the drawing. So let us all decide on the right tool for the job. What tool would you use to find CD in this diagram, this quadrilateral, which is made up of two triangles? What tool would you use? What tool would you use? I mean, if I look at CD, there's an angle opposite that, and then I also have an angle side relationship going on there. So I'm very much feeling the sine rule. So something like that is what I would start with, and I would use the sine rule. I want you to find me what the value of that CD will be in the end. I think Stephen and Simtanda has pointed in the right direction. I'll be back in a second, but I want you to try and do that for me. So the way the sine rule works is you go the sine of the angle opposite that side, and then you look for another pair, which is going to be 52 over the sine of 60. And then you need to move that sine of 80 to the other side, so you get 52 times the sine of 80 over the sine of 60. Now, we obviously have to put this all in our calculator and get a value. So I want to see what everyone is getting. I get, like everyone in the chat, 59.13. Okay, cool. So we have got, this is 59.13 meters. Next, let's go and find AD. Now, AD is sitting up here in our drawing, and I would love some tips from the class about what tool they think will get the job done this time. Look at what you've given and ask yourself, what tool do you think will suit this situation? What tool do you think? What are we given? We're given a side, we're given an angle, and we're given another side. But the problem is it's not easy to use the sine rule. This, you actually have to use the cos rule. And since you are focusing on sides, remember with the cos rule, when you're focusing on sides, it feels a lot like Pythagoras. It has something squared plus something squared, and then it has minus 2, and then it has the cos of the angle in between. So I think you need to use that template to help you find AD. So I will give you some time, see if you can find me what AD is. Can you find me what AD is? Do you know what numbers go where? So we know this is 74. We know this is 52. 74, 52, and then the cos of 36. But we have a problem because that's squared. So to undo the squared, we need to square root both sides, and then we'll get what AD is. So I'm going to have a look at the chat, and I see Annalena and Siamtanda have given the same amount, and if I look at that, that does look correct. It's 44.20 meters. So this is 44.2 meters. Okay, last question is to find the area of ABCD. And this reminds us a lot of last time, where you have to find the area of a quadrilateral. And what we did in the previous question, we said, look, no problem. We'll just take this quadrilateral and we will divide it up into two triangles. So can you take that idea and find the area of each of those triangles, and then afterwards we can add them together to help us figure out the area of the quadrilateral. Okay. I'll give you some more time. And then I think we're due a break. Definitely need a break. We've done a half an hour of solid maths. So what have we got? We've got the second triangle has a bit of a problem. Who spots the problem with the second triangle? First triangle was easy. Second one was a bit harder. Who can spot? The problem there. Yeah, you don't have the angle you want. Yep. Siamtanda, can you see a way to get around that problem? Is there any solution you can offer us? It's almost like we really wanted to have this angle here, because then we would have two sides and the included angles. So, we know that this is 52. We know this is 59.13. What we don't know is what that angle is. You can turn your mic on if you want, Simtanda. That's not a problem. If you have an idea, or put it in the chat. Ooh, you're right. So if this is 80 and this is 60, we know this angle, all triangles add up to 180. And so this needs to be 40. And so that would be 40. So if you work out the area of that and you add it to that, you will get your final answer. So let's do that. And you guys can tell me in the chat what you get. 52 times sine of 36 plus 2 times 59.13 times sine of 40 equals. What is everybody else getting for their total area of the quadrilateral? I've got my answer, but I want to see what you guys get. So we're just taking whatever we get for this one, and then we're adding it to that one. On my calculator, I get 2119.107, or we'll just say 12, and that would be units squared. And as I look at the chat, I see Selakani and Siamtanda have got the same thing. So I'm feeling pretty confident. Okay, we've had a solid half an hour of maths. Let's all just stand up for a second. We know that sitting down for a long period of time, our legs will start to go to sleep, and our body is just happier when it has blood flow. So let's just take a couple of seconds to just stand up, maybe roll the shoulders a little bit, just loosen up, shake out the arms a bit, and just breathe in some air, step away from your bed or your desk, wherever you are. And all we're going to do is we're going to do a jumping jack, 15 of them. This is a jumping jack. And what a jumping jack does is it just gets our heart rate up. We forget about maths for a bit. And it just, yeah, it helps us recharge so that we keep learning well after this. Okay, make sure you're not going to whack anybody or anything. And we'll start now in 3, 2, 1. Let's go. 2, 3, 4, 5, 6, 7, 8, 9, 10. Almost 5 more. 1, 2, 3, 4, 5. And just take a few seconds to feel your heart pumping. Cool. I can definitely feel that in my body. Oh. And then what I would like you to do is I want you to hit one of the emoticons on the thing. So I'm going to hit the heart one because my heart is pumping. But if you want to have a happy smiley face or a laughy face, it's up to you. But just hit a emoticon so I know that you have had a little break and your brain is like, it's had a chance to just switch off for a second or two. Oh, I see them. Fantastic. Okay, let's just do a couple more questions. And I'm going to make this a little bit harder now. But what I'm going to do is I'm going to go through it with you. So if we look at this question, this is a past exam question, just like the other ones I've shown you today, but it has a bit more what I call fluff. Like this looks scary just because it's a whole bunch of detail, but all it's really referring to is here, like where they're saying, this is a side, it's 2x. This is a side, it's x. This is a side, it's 3. This is a side, it's theta. They then go and say, show that this is true. Now, the important bit really is the verb, the action word, the doing word. Show that is true. Now, if you think about this section, it's solving triangles. If you want a cos theta, what rule do you think I should use to find a cos theta from somewhere? What rule do you think I should use to find a cos theta from somewhere? Any ideas? I was thinking we have the sine rule, the cos rule, and the area rule. Let's just use the cos rule and let's think, what is the template? So if I have the cos of an angle, theta, I then have a fraction. If I then write the template for this fraction, I know I always have a minus something squared there. If I look at the drawing, does anybody know what is going to go inside of this part here? Does anybody have a suggestion? Simtanda, you have smashed it. Yes. So this is opposite theta. And so this has to be an x squared. Oh, sorry, an x, not an x squared, because the squared's already there. Okay, now if we think about how the cos rule works, it then has these two parts here and these two brackets there. What do you think is going to go into those brackets? What do you think is going to go into those brackets? if we look at the drawing, what do you think is left here? Well, if I've used up the x over here for that one opposite there, the other two sides, there's a 3 and a 2x. So I'm going to put a 3 and a 2x here, and I'm going to put a 3 and a 2x there. So the good news is I've subbed all of this stuff, and I'm on the road to figuring out what this is. But it still doesn't look like that thing down there. What do you think I should do next? What do you think I should do next to get closer to that thing down there? Who has any ideas? So CM Tanda said, look out for like terms. Well, let's see if I can see if there are any like terms. 3 squared is 9. Okay, I don't know if the 2x squared is going to be 2x times 2x, so that's 4x squared. And then this is minus x squared. On the bottom, I've got 2 times 3 times 2x, so that is going to be 12x. Are there any like terms? Siam Tanda, you're quite correct. 4x squared and minus x squared are in fact like terms. And so I can simplify this to be 9 plus 3x squared over 12x. Now, it still doesn't look like this yet, but I'm getting closer. Who has any other ideas about what I could do to get that to look closer to what's in the window there? LCD Silicone, you on? It's almost that. I was thinking what we call take a factor out or factorize. So we take out a 3, and if we do that, we've got 3 plus x squared on top. Then on the bottom, we have 12x. Okay, now that's a good sign. Now, what we really want is a 4x, but you know what I've just realized? 3 goes into 12 4 times. And then what we are left with is on the top is 3 plus x squared, but we can say x squared plus 3. And on the bottom, we can say 4x. So we know that cos of theta does indeed equal x squared plus 3 over 4x. Because remember, if something is plus, you can rearrange the order, and then 3 goes into 12 4 times. Okay. Give me a thumbs up if you followed me there. Give me a thumbs down if you didn't follow me. Okay. Any thumbs down? Don't be afraid. Thumbs up, thumbs down. Okay. I'll just go over the key steps. I looked at this and I saw cos of theta, and it meant I used the cos rule. Then I wrote down my template for the cos rule, and I looked and said, what's the side opposite? And I said, it's the minus x squared there. What are the two other sides? I plugged them in. I then sort of simplified and worked with the algebra, and I got down to this step. Then I took out a common factor of 3, and I found that equivalent fraction. 3 over 12 is the same as 1 over 4. And then it looked like the final thing there. Okay, let's go to the next part of this question. So what we have is it says, calculate the size of angle theta. Now, angle theta is just sitting up there. So let's just get rid of this first. But there is some other information that they tell me. They say x is equal to 2.4. Now, if x is equal to 2.4, why is that information helpful? Because it says find theta, but before that, they tell us x is 2.4. Why is that information helpful? Does anybody have an idea why that might be helpful? How can we use the 2.4 to help me find what theta is. What should I do with the 2.4? I was thinking, why don't we take this 2.4 and put it into this relationship, or what's here? So if we say the cos of theta is something squared plus 3 over 4 times something, and they tell us that x is 2.4, well, we can put that 2.4 here. Now, can you work out for me what this angle theta is, which is here and over there? I'll give you a moment or two to find out what that angle theta is. I think we need to use inverse cos on whatever that fraction above is. So whatever this thing is, we need to use inverse cos to get that. So let me go. Shift cos fraction button. 2.4 squared plus 3 over 4 times 2.4, close brackets, equals, and what I get is theta is 24.15, because I'm rounding up, so 15. So this angle is 24.15. Okay, last question here is determine the area of PQR. So I need to find the area of this triangle. But I have a little bit of a problem. The problem is I only have one side, which is 3. The other parts are variables. How am I going to find the area if one of the sides is a constant and the other ones are variables? What mathematics do you know? What do you notice in the question that might be able to help me? What do I have to see to find the area of PQR? It would be so nice if I knew the length of that side, because I know the area of a triangle is a half a side times the side next door times the sine of the angle in between. I know that this is 3. If only I knew what that was. Siddhakani, I think I'm with you. It says solve for x, but you know what? You already have x is 2.4. So I think I'm going to say x is 2.4. 2 times 2.4 is 4.8. And then I'm going to take my 4.8 and put it there. And then in the previous question, I found that this was 24.15. So what do we have? I think we now just have to push this into our calculator, and then you can figure it out. Find me, oh, there we go. Annalena, you spotted it too. Find me the area of this triangle. What do you find the area of this triangle? So I'm going to go a half times 3 times 4.8 times sine of 24.15, close brackets, and we get 2.95. So it's going to be 2.95, and it's going to be units squared, because it's the area. It's literally how much space fits inside this triangle. Okay, that was a toughie, but I think it's good for us to see a couple of the harder ones. But I thought you did very well. And if you need to, you can re-watch the recording tomorrow just to help it get into your head. Okay, let's have a look at... Okay, we're not going to be able to do the whole question here, but we can do part of it. So first question says, here is some fluff, but this fluff over here is going to be on the drawing here. I see an angle over here, which is, I'll say it's the yellow one. It's alpha, or yeah, and then we have theta, which is the biggest one here. It says, write down the angle ACD in terms of, so what is ACD? There's ACD. So basically the green angle is ACD, but it says write down, oh no, I lie. I'm telling a lie. Sorry, everyone. It's ACD is actually the angle that goes like that. And they want you to write down what this angle is in terms of theta and alpha. So who has an idea? How do I write that blue dot angle in terms of these two angles here? Simtanda, I'm so happy to see that hand. Let me please unmute yourself and let us know what you think we should do.
I think we should look at the whole angle theta and minus it by alpha.
That is absolutely perfect. Yep, and this happens a lot. So you go theta minus alpha, and that is what this blue angle over here is going to be. You take the big one and you take away the green one minus the yellow one is what we do.
Yes,
okay,
sir.
Thank you so much.
Good.
Okay, now, because time is limited, if there's enough time, I will come back to 6.2 to help you. But you know what a lot of students do is they freak out about 6.2 and they forget that they don't even need to answer that to do 6.3. So I want you, before I do 6.2, I want you to do 6.3 for me, just really thinking about what's on the page. And if you get stuck, I want you to ask questions, but really you can answer this question using 6.2 and what they give you. And what they ask is, what is the length of AD? And AD is just sitting up here, but you can use what they've given you to find what that is. What do I really need to do 6.3? What do I need to do 6.3? Sub in. Yes, Silicani. Yes, you do. This is what's so fantastic. And a lot of students, they do obviously get worried because they see all the stuff and they're like, how am I meant to do it? But really, all you need to do 6.3 is use what's already there. So you need to fill in. H is 17. So there's a 17. So I've used that. Theta is 58. So we go 58 minus, what is alpha? Alpha is 23. Do that. And on the bottom, I've got cos of alpha. So that would be 23 as well. So I literally use this to help me. I plug those values in. What do I get for AD? What are you getting for AD? Okay, let me use my calculator. 17 times sine of 58 minus 23, close bracket. And then we're going to go divided by the cos of 23, and we have 10.59. So this is 10.59, and that is going to be units. So just so we know, that is 10.59. Okay, we've done this one, we've done this one. Let's do area of ABC. So you need to work out what the area of ADC is. Now, where is ADC? That is a triangle, which is here. Actually, let's do this. Now, you've just worked out that that is 10.59. How are we going to figure out the area of this one up here? It's actually quite a tricky question, but I'm going to help you see in a moment. So, and we also, let's write in, theta is 58 and this is 23. Can we work out what this angle over here is? This one missing over there. Any ideas? Oh, we also know in the question that this is 17. Simtanda, let's go to you. I see your hand is up. I'm sure you can help us out. What do you think we should do?
We should minus 58 from 23.
Yeah. And what do you get? Let's have a look. I get 35. Did you get 35? Okay. So I agree, Simtanda. So if that's 35 and this is 23, that's 90. Flip. Okay, we're almost there. If only we had a way to work out what that angle over there was, because we've got the two sides, we need the angle in between. We know this is 35, we know this is 23. Does anybody have an idea about what we could use? Well, we could use the problem with the cos rule is we don't know the length of this side over here. To use the cos rule, we need to have a third side. We could maybe use, we can't use that. Do you know what we need to do? I'll give you a hint. If I know what that angle is, there we go. Annalena has helped us out. The blue one is 90. The black one over here is 58 together. What does that mean that this one over here needs to be? What does that need to be? That green dot over there. We'll call it angle CAB. What does that need to be? Well, I'm going to go 180 minus 58 minus 90, and I'm going to get 32. So that's going to be sum of angles in triangle. I would like you to now work out the area of triangle ADC. Please work out for me the area of triangle ADC, and we'll finish with that for today. This question over here I've done in a previous video of mine, which I will share with you guys, and I'll show you at the end today. But that's a nice one to finish on. What is your area going to be here? Okay. Well, we know for the area rule, half base, well, a half times the side times the sine of the angle in between. And we know that that was 17. That was 10.59. And this was 32. So what is the final area of my triangle going to be? And I'm going to put that into my calculator too to help. Thanks, Annalena. I see you got that 32.5 times 17 times 10.59 times the sine of 32 equals What are you getting for your area? What are you getting for the area of your triangle here? I get 47.70, and this would be units squared. And I see that Annalena agrees with me, and I'm sure that many of you do as well. Okay, everyone. So this is the last example that we're going to do tonight.